Hey, what's up everybody? This is Easy Speeds and Feeds. Today we'll be making a vacuum fixture. This video will be about an hour and 20 minutes long, so it's a long one. Um, let's get started. So, we're in Mastercam 2021, and what we want to do is start creating the vacuum fixture. So, we want to make an aluminum block, so we're going to draw some wireframe. And then we're going to make our width 6 inches, height 6 inches, so 6 by 6. Next, we want to go to solids and click on extrude. Click on our wireframe, click the check, and we'll give it a distance of, we'll go 3 inches. So there's our block. This is the very start of our vacuum fixture. So we start with a block. Next, we click on curve all edges under wireframe. So we give that block, all of its edges will have wireframe, so we can click on it and program off of it. Next, we want to duplicate that top plane. We'll call it our build plane, and we'll move it over to the side of the block. We'll rotate everything so we kind of have a view of this side looking down. So rotate our Z 90 degrees. Rotate our Y, click the check. We need to change that view because that's not quite what we want. Okay, that looks good. Now we are going to build the hole that the vacuum plugs into. So we kind of want to do what we did before. We want to draw some wireframe and then extrude. So first we'll draw a line. Oh, that's going the wrong way. Make sure our construction plane is correct. We can delete that line. We'll try this again. Length, we'll type in 3/4 of an inch. Next, we want to go to easyspeedsandfeeds.com and find a pipe tap, because that's the fitting we'll be using. We'll be using a pipe tap fitting. And we're going to go to NPT NPTF. And we'll use 1/4 so the hole we need to leave is 437 thou. So that's what we'll do. Make a circle that's 437 thou. Okay, so that hole, we want it more towards the bottom. So we'll redo these steps. And why we want it towards the bottom and this fixture extra thick is so we can reuse this fixture over and over again. If it was a thin fixture and we machine the top of it, we can maybe only get one use out of it. But if it's 3 inches thick, we can shave off the top and then remachine it in for a different part. So, okay, so we're extruding that hole. We want to go 5.5 inches into the fixture. So our fitting will fit in that hole, our 1/4 18 and the vacuum will plug into that hole. So this is the beginning of our vacuum fixture. So we're just checking everything here. So what we want to do is merge this vacuum fixture with our part. I'll show you guys how to do that. So we'll save this, save it to my desktop, call it vacuum, call it vacuum chuck. Alright, so here's our part. It's very thin. And what we want to do is merge our vacuum fixture into this Mastercam file so we can put this part on top of it and then start designing how we're going to hold this part. So as you can see, that's 50 thou right there. So we definitely want to hold this with vacuum, pulling it down so we can machine this thing and we can machine it accurately. So we go to File, click on Merge, and then we want to go back to desktop where we saved it, click on Vacuum. We clicked on the wrong one. That's the vacuum part. We want to click on the vacuum chuck. So File, Merge, we go to desktop, click on vacuum chuck, and there it is. So that's how you merge two files in Mastercam. Okay, so we got lucky and it kind of positioned itself really well. So what we want to do, since we have all these solids, is we want to split them up on different levels. So we can activate different levels and just view either the vacuum chuck or the part or their wireframes. So we'll create a level 3, call it vacuum chuck, create a level 4, call it vacuum chuck wireframe, and we'll start moving this stuff around. So we'll select all wireframe and we'll move it to level 4. Next, we'll click on the vacuum solid and we'll move it to level 3. So now we can activate these different levels and view our different solids. So here's our vacuum chuck. There's our solid part. That's pretty important. You keep everything on a different level so it's all organized and easy to work with. So we're going to rename the plane 100 to build because we'll be moving it all over the place. Move that plane to the bottom of the part. I want to select the part, go to wireframe, and click curve all edges, or silhouette boundary actually. this will just make a boundary on this face. But we went with curve all edges, and then, which both work. So we'll just click on all this wireframe. And we're going to move it to level 4. So we're moving that wireframe to the vacuum chuck level. So now we can go to the vacuum chuck level. And deselect our part. And now we have an outline of our part on the vacuum chuck level. That's kind of the first step of building a vacuum chuck, is you need a profile of your part. So we're going to move our build plane, the top right corner of our vacuum chuck, and we're going to start designing and extruding and adding wireframe to this vacuum chuck so our part can fit in it. So we're going to draw a line, and we're going to draw a point, and that point we'll draw a circle on it, and then we'll extrude all the way down to that hole we put in earlier. So we'll call it 300 thou. And we are going to extrude that hole all the way down to our hole we put in earlier. That will create an airway. So the vacuum will pull through the hole on the side, suck air through there, and then it will go up to where our part is. Okay, looks like there's a good intersection there and it's not breaking through. So next, we are going to create circles on all the corners of our boundary. What we want to do is we want to relieve the corners so when we go around with an end mill, the part can fit in. See, if we didn't do this, the end mill would leave a radius in all these corners and our part would not fit in there. So now we're going to go around and we're going to break up the wireframe so we can eventually add radiuses to these circles and create a much smoother looking boundary that we can program off of. So now we're going to try to add radiuses from our profile into our circles. And this takes some time because it's very easy to screw up and add the radius the wrong way. So you may need to break up your circles into smaller bits of wireframe. That's exactly what I'm doing right here. So 3 circles done, we'll go break up this one too. So we can extrude that profile down. So let's extrude it down 50 thou. So our part can sit in that pocket. So we got an airway into this pocket. The pocket has a profile the same of the outer profile of our part. So we got 2 steps down. And we're making some progress here. Next, let's select the entire thing and let's add wireframe to all the edges. And we'll create another level, call it Vacuum Pocket Wireframe. We can move all this wireframe into that level. Again, keeping everything organized is pretty important when you have multiple solids and lots of things going on like this. Next, we're going to select the wireframe on the inside, move to level 5, and we want to, okay, so we selected that. We want to transform this wireframe out. Actually, we don't. We want to chain. Yeah, we want to chain this material out. So we just screwed up there. We're going to click the back arrow after we save this. Yeah, so we'll come back to that step later. What we want to do right now is redo this wireframe real quick. And I'll show you guys why soon. I'll explain it now. What we want to do is we want to add wireframe so we can make some seals. So what we're going to do is we're going to add 2 rubber gaskets, one on the inside and one on the outside. The rubber gaskets are going to what keeps the vacuum sealed in. And it'll be much easier to visualize after we add it in. So right now, we want to kind of redo what we did earlier and have that square profile. We want to trim all of that together so we have some nice corners in there. And again, we are on the rubber gasket step. It'll be a lot easier to visualize once I show you guys. So we're adding the wireframe right now. We got our corners in there. We're going to go to chain. This is important. We want to click on that outer profile. Okay. We want to click on the inside. We want to make the distance 50 thou. So that looks good. This is going to be the beginning of our gasket groove. So we'll clear our colors and we're going to do that step again. After, we're going to first add some radiuses because a gasket doesn't fit in a square corner like that very easily. So some 200 thou radiuses should work out. Okay, so left over some wireframe that we don't want. We're going to trim that away. Or in this case, we're just going to break up the lines. Okay, so that's looking good. Oh, still got some more. So we're going to chain like before, select the inside, make the distance 104 thou. It's recommended that you go 100 thou with this gasket, but I just go just a little more. So that's the outer profile gasket. Now we need an inner one because there's a hole through this part. We'll go 50 thou to start and then do that again. We'll go 104 thou. Okay, so we clear the colors. Now we got two gasket grooves, one on the outside, one on the inside, to hold that vacuum in. It's going to come through that hole, and then that vacuum is going to be trapped within these two gaskets. Next, we want to extrude this gasket down. $90 thou. Next, we want to do the inner one also. So we go to extrude, select our wireframe, go down 90. So those are two gasket grooves that trap our air. If we didn't have the inner one, it could escape through the hole that goes through the part. If we didn't have the outer one, it could escape like through the corners of the part. So next is like the fun part. We're gonna draw our airways. So it comes through that center hole, right? What we have to do is draw a wireframe maze in between our two gasket grooves. And what that's going to do is create like a suction that applies to the entire part. So we'll create another level, call it level 6. And we won't do any extruding here. This is just going to be a wireframe thing. So we'll start out with a simple rectangle, like that. Next, we're going to draw wireframe that crosses through that pathway. And we want to cover as much of the area in between the two gasket grooves that we can. What we're going to do after we draw all these airways is we're going to take a ball end mill and machine along the center of this wireframe, and it's all going to lead back to this hole. So it's going to come through the hole, and then the air is going to go through all these grooves and create a suction on this part. And if we have wireframe that goes almost all over the surface of the part, it's going to hold it down really well. So again, we're covering almost the entirety of the part without intersecting the gasket grooves. You can't have an airway that does that, otherwise you'll lose vacuum. You want to keep the vacuum within. Okay, so that's looking good. And what we're going to do is we're going to machine this entire thing. We're going to program all of it so you guys can visualize this thing. So next, I'm just going to select all that wireframe I drew. And I'm going to move to level 6. Again, organization is key when doing something like this. And there we go. We got a start to our vacuum fixture. What we need to do next is program all the tool paths and then run this thing and verify so you guys can see how the part will sit in. So what we want to do is we want to drop this part in the pocket. We want to visualize how it's going to look like. So we'll translate the wireframe and that solid down 50 thou. Next, we'll just select the solid part and solid vacuum fixture, and that is how it should look in the machine. So our part is sitting on those two rubber gasket seals, and then our airway should pull it down. So that's pretty cool. That's a cool setup. It's going to work really, really well. So we saved it. Now we want to add toolpaths, and we want to run it through verify and double check how it's going to look. Okay, so now we want to machine this part. So we're going to set up our toolpaths. First, when you set up our machine, we're going to go to Mill, Default. And we need to get our Machine tab back open. It's not there, so we're going to go to View. And then we're going to click on Toolpaths. Delete one of those machine groups. Okay, so we got our machine definition. Now we just need to start adding some toolpaths. We'll duplicate the build work coordinate system, call it 100. We're going to move the gnomon to the center. We're going to check it's at the right Z level, which it is. Then next, before we do our toolpaths, we want to just add some stock. So we'll create a rectangle. And we'll pretend our stock piece of aluminum is 6.25 by 6.25. Create another level and call it stock. Op 100. So we can move that stock to level 7. Keep everything organized. Okay, now we can start adding some toolpaths. We'll do a facing toolpath first, and we'll select the stock. Click the check. Go to Tool. Go to Filter. And we want to find a 1/2 inch end mill. We'll edit the tool. And this tool, we're going to edit it and make it extra long and undercut. Next, we want to make the tool number 1. Our speeds and feeds, we'll go to easyspeedsandfeeds.com and we'll start calculating out some speeds and feeds for this extra long tool. So 500 thou diameter, surface feet, we'll use 600, number of teeth, it's 3. 3 teeth, and then inch per tooth, we're going to use 5 thou. But with the end mill being so long, we're going to crank that down a little bit to 3 thou. So we'll type in 40 inches a minute, 4,500 RPM. We'll go zigzag, put stock to leave on floors at 0, click the check. Let's see what it generated. Okay, that looks good. Next, we want to contour around this part. cut parameters, we will be doing a ramp, linking. We're going to select our depth here. We'll type in minus 3.1 to go 100th further than the bottom. Our ramp, we're going to do it by depth. We'll make it a depth of 1/4 inch. So every time it goes around the perimeter part, it'll go down 1/4 inch in Z. Finish, we'll do a 10th finish. That all looks good. We'll regen our speeds and feeds. So there we go. We face the part and we're doing a ramp around the part. Now we go to stock setup. We should have done this first, but we can do it now. Select the 100 plane. Click on bounding box and select the stock. Type in our Z value of 3.25. Click where the work coordinate system is. We'll type in 10th for Z, so it takes off 10th off the top. Now we can verify. We'll be using a lot of verify for this video. Okay, so that looks good. That's doing its finish pass. Awesome. So pretty simple so far, just facing and contouring around the part. Next, we'll create a new toolpath, call it 200. Rename the first machine group to vacuum chuck. So this is vacuum chuck operation 200, or operation 2 you can call it. So we'll duplicate level 100, we'll call it 200, and we'll move our gnomon to the other side of the part. Click the check, and now we're ready to go. Toolpaths, we want to probably dynamic mill all the stock off the back. We can do a peel mill because facing it might take a while. We'll select a couple lines for our peel mill to follow. Click the check. And we're going to select a different end mill, a stubbier one, so we can take the material off faster. So we just select a 1/2 inch, we'll edit the tool. Click next, call it tool. We'll have to switch that, but we're going to look up speeds and feeds right now. We use 1200 surface feet, and we'll crank up the inch per tooth by to 5,000. So that's much faster than our last tool because it's stubbier. Okay, we'll type that in, 130 inches a minute. Go 9,000. Cut parameters, stock to leave on walls, 0, stock to leave on floors, 0. We'll add a depth cut, and we'll put in a finish step. Our depth will be 0. we'll go ahead and generate this toolpath and just see how it looks. We'll make some changes, but we're just going to see. Okay, so that's looking good. We'll select both of our ops and we'll verify. So we got a couple problems going on here. Our peel mill isn't taking off enough material, but also our contour did not go to the correct depth. And also our peel mill finish pass is taking off too much. So we have some changes to make. So first, the peel mill, we'll change this around. Stock to leave on walls will go minus 300. So this could go 300 thou past that wireframe. Finish step will go 5 thou. Contour ramp, we need to change this too. Go to cut parameters. Make pass at final depth. So we're going to regen that and regen the dynamic peel mill. Now we go back into verify after selecting those two. Now we're going to watch this again and see what happens. So it looks like it's going to the correct depth now. Our peel mill is taking off all the stock. That's what we want. Okay, so we got a block. After this, we need to, so we got op 1 and 2 done, we need to add the side hole and our airway, and then we can start actually machining the pattern for the vacuum, actually make this thing a vacuum chuck and not just a block. So as before, we're going to call our next toolpath 300. We're going to duplicate our plane and call that 300. Keep everything organized. And we're going to move it to the face with the hole. Now we did just make a mistake. We didn't duplicate 200. We just moved it, so now we have to move it back and regen operation 200. So let's regen that toolpath. Now let's duplicate 200, call it 300. Now let's move that 300. That is the correct step, correct way of doing it. Okay, so we'll pick up off that corner. Rotate our X and Y around. Now we can drill this hole out. So select that hole, click the check, go to Tool, first we're going to correct a mistake here. We'll turn that Tool 1 into Tool 2. That was a shorter end mill, and the Tool 1 is a longer end mill. Now, we need to find a spot drill big enough for that hole. So we'll click Filter, click on None, find the spot drill, Now we'll use 3/4 of an inch because you have to keep in mind a quarter 18 NPT tap is going to go in there. So this needs to be a big spot. Call it tool 3, go 3 inches a minute and 4,000. Drill counterbore, that looks good. Linking, we want to add a clearance, 2 inches. Now we want to calculate our depth. So the finished diameter, we want it to be 5 inches 50 thou, and it calculated how far it needs to go and added it in. So we'll overwrite the depth. There we go. So again, we're going to select all of our ops and hit verify. Verify does take a moment to load and watch, and it seems like you're slowing down, but it can also show you if your tool rapids through the part, or if you have a tool in the linking parameters on absolute or incremental where it shouldn't be, and it rapids through your part. It can tell you a lot that you don't even know is going on. So I highly recommend verifying everything multiple times. So it spotted it. The spot is bigger than that hole, which is good. So that'll be a nice lead-in for our quarter 18 NPT. Next, we'll go to drill again. We'll select that hole. And we want to select a drill big enough and long enough, actually, because we have to go 5.5 inches in. Find drill, click the check. Now we're going to find a drill that's 437 thou, 7/16. Right click, click edit. Now we want to adjust some things on this drill. First, we'll call it tool 4. Speeds and feeds, we'll go to easyspeedsandfeeds.com. Go down to high speed steel drills. Type in your tool diameter. Type in the surface footage you want to use. I typed in 200 because this is a longer drill. We'll go 5 thou. So we're going a little bit lighter just because this thing's long. We don't want any chatter as it's entering that hole. Feed rate 8, spindle speed 1750. Linking parameters. We'll change drill counterbore to pec drill. We'll go 25 thou increments. We'll click the check. Call it good. So on that toolpath, I made a couple mistakes. The linking parameter should have been minus 5.5 inches, and we didn't edit our tool to be long enough. But all that will be picked up and verified later in the video. Next, we're going to go for tap. Now, we can't actually find the quarter NPT tap in Mastercam, so we end up skipping it. But you could probably easily draw or create the quarter NPT tap, but we just didn't have time for this video, so we skipped that. Here's the page in which you could create that core 18 MPT tap, but it would take so long. We just want to stay on track, and we'll just pretend like we tapped that hole. So we're going to run verify. Okay, so it looks like it's doing everything except drilling that block. But I didn't pick up on it yet, so we're moving to operation 400. So we duplicate 300, call it 400. Then we move the gnomon to the face we want to machine, which is the face with the vacuum pattern on it. So we're going to move our X and Y around. And now we can start machining our vacuum pattern and turn this block into an actual vacuum chuck. So, first thing we want to do is dynamic mill out all the stock we can. We'll activate the necessary levels to do that. We're actually going to add a level called Op 400 Pocket. And we're going to select this block, do curve all edges, we'll click the check, remove all that wireframe to level 8, so Op 400 Pocket. So we call it Op 400 Pocket because this is Operation 400, a work coordinate system 400. So everything's organized. We can go back and select all the proper levels and planes and edit things easier. So new toolpath group called 400 to go with our plane and level. So we'll click on dynamic. And we are going to select the appropriate wireframe. Now we're having trouble here because we don't have chain in the selection method. We have single line selected where we should have chain, where it just auto chains a bunch of connected wireframes together. So we play around for this for a little bit, and then we realize that we don't have chain selected. See, it says 11 where it should just say 1 in machining regions. You want 1 machining region. Now we go ahead and select our tool. Choose a 1/4 inch. Call it Tool 5. We go to easyspeedsandfeeds.com. Go up to milling. Type in 1/4 inch. We put our surface feet at 700 because our spindle only goes 10,000, so we can't go the max surface feet. Inch per tooth, we go 3 thou. We go 2 thou 5/10 actually. We type all that info in. (10,000 RPM). We click finish. Our depth, we select it. So 50 thou, that seems right. Plunge angle, we go 1 degree. Depth cuts, we add a finish pass. (5 thou). Okay, so we try to generate this toolpath here, but because we didn't have chain selected, it couldn't create a toolpath. So we deselect all those. We try this again. We click on everything. So we figured it out. We didn't have chain selected. So when you go click on chain, it should auto chain all the wireframe together. It didn't this time, but it should only be 1 machining parameter, not 11. So we zoom up and make sure we get that last little piece. We'll click the check, and machining regions is 1. Now we can regen that toolpath. And it looks like you made a good toolpath there. Next, we want to measure the distance between those 2 corners. And we want to make sure that a 1/4 inch end mill can fit in there. And through our measurements, we find that's 212 thou. So a 1/4 inch end mill will not fit in there. So we have to add another toolpath that can work. So we're going to select that wireframe again. Go select library tool, click on filter. Click on flat end mill. We're going to find a tool that can fit in there. Go with an 1/8 inch. Edit the tool. Click next. Tool number, we'll call it 6. Next, we go to easyspeedsandfeeds.com and find some speeds and feeds for an 1/8 incher. We'll use 350 surface feet. And for inch per tooth, we'll use 1,000. So we go 30 inches a minute. We'll go 10 grand. We'll just do 2D. Our depth will be 50 thou. Multi-passes, yes. Depth cuts, no. Click the check. Go back into parameters. Go to lead in and lead out. We'll change it from, we'll just turn them off. I didn't really like the way that tool path generated, so we'll regen that. And we're going to run a verify here. So it's dynamic milling out all that stock and it's leaving those corners in there. Then next it goes in and contours. So that contour looks good, but it left just a little bit of stock in the middle. We want to remove that. So we're going to do a drill move. And we're just going to select the center of those circles. And we're going to drill with the 1/8 incher. Or the 1/4 incher, that works. Feed rate, we're going to just go real slow. We'll call it 3. Depth, 50 thou. We'll just do drill counter bore. So we'll click on vacuum chuck, click verify, and we'll see this time if it leaves material in those reliefs, those relief corners. So it looks like it took that material out, which is good. Yeah. So that's a good start to our vacuum block. So that pocket will hold our part. And we still need to add the grooves. So we're going to select those grooves. Okay, we have the outer selected. Now we'll go to Tool, select Library Tool, click on Filter, or actually, there it is. We'll use a 3/32. Click Edit Tool. And yeah, we'll make it Tool 7. So 7. Now time for more speeds and feeds. We type in all of our information. Feed rate 15, spindle speed 10,000. Cut parameter, we'll do ramp. Now for the depth, we'll select the wireframe at the bottom of the groove. Okay, 140,000, that seems right. Top of stock is 0, that's good. Ramp, we will ramp that groove at 50 thou, and that will go minus 50 thou and Z every time it goes around the perimeter or the profile of that groove. We'll add no multi-passes. We'll click the check. Now we need to add more geometry. So we'll select the other side of the groove. Because this groove is 104 thou wide and we're only using a 93 thou end mill, so we need to hit both sides. Now we can actually add the chains of the inner groove. And keep in mind, these grooves are for those rubber gaskets. So that looks great. Click on Vacuum Chuck, click Verify. Let's see how this thing looks. So that looks great. So we got our pocket, we got grooves for our rubber gasket we can stuff in there. Next, we just have to add the airways, and pretty close to done. So we go to drill. We're going to spot this hole and drill it through to the hole that comes through the side. So we can use that 3/4 inch spot from earlier. Depth, we're going to go minus 50 plus. We're going to calculate our finished diameter of 350 thou. We're going to add it to the depth. So that should be good. We're going to double check the diameter of that, make sure that a 350 thou spot is good. And that's a 300 thou hole, so that'll work. So next we can drill that hole. We'll call this tool Tool 8. Speeds and feeds. We'll go down to high-speed steel drills. We'll type in our info. "25 inches a minute, 5,000 RPM, cut parameters, pec drill, 25 thou, linking." We're going to select the center of our side hole as our depth. Okay, so mine is 2.5. Now we can click on Vacuum Chuck, click Verify, and we can see what's going on here. So that looks good. Looks like it's drilling that hole into our hole from the side. But here I realized that I screwed up earlier. So we can change our tool 5. We'll change depth to 5.5. Click the check, regen it, and re-verify. Now because of verify, I can tell that I made a mistake. Without using verify, it's kind of hard because you can't visualize what's going on. So again, we made another mistake. We didn't edit our tool. So we can go back to that pec drill. We can edit that tool. Change your overall length to 7 inches. Give verify another go. Through verify, we can tell that I keep messing up. So we can continue to play around, and I talk about verify a lot, but it's really good because you can tell, you can go back and forth from creating tool paths to visualizing what they're going to look like. So it's great. The cut length is what we needed to change. And with verify, you can experiment what does what. So through verify, you can learn more and more about Mastercam. So it looks like we have a side hole now. We learned that the cut length needs to be just long enough, and that the overall length doesn't matter so much. Okay, so now what's left is the airway. Now we can activate our level, the airway, deactivate level 8, and now what we want to do is just select all those wireframe lines we drew. So now we want to select a tool. We use a ball end mill, 3/32. We'll edit the tool. Call it tool 9. Feed rate, we're just going to go really slow. We won't calculate our fastest speeds and feeds. We'll go 5 inches, 7,500 RPM. We'll go into cut parameters. First, we'll do linking. We'll find a depth. We'll go -50 plus some, so we'll go -90. Now we can do another verify. Actually, we go back into parameters. We forgot a step. We go to cut parameters. Compensation type, we'll click off, so it goes down the center of that wireframe, not off to one side. No lead in or lead out. We'll regen it. We'll watch a back plot. I don't do much back plot, but for this one, I'll use it. And it looks like it's going down the center of that wireframe. Okay, so that looks good. Now we're going to verify it. So that looks great. So it's a nice maze-like airway that's going to pull down on our part. And the more you can make that maze cover more of the part, the more even of a vacuum you'll get. So we have a side hole that the air comes through that goes into our pocketed vacuum fixture that holds our part down, and we have a nice tight profile that holds our part into place. So I am going to add links to the vacuum pump I use and also the rubber seals you can get at the end of the video. And if you guys have any questions, just comment. I'll try to respond. But yeah, here's our vacuum fixture video. I hope you guys liked it. Subscribe for more stuff like this, and we'll see you later. Thanks.